user.
Yeah. So, good morning, everybody. Very nice to see all of you. It's a really an exciting opportunity for me to interact with you because being a technologist from by profession all my life, I have taken deep interest in systemic approach to um, defining and solving problems. Systems thinking has been always. I'm an explorer in system thinking, and I'm also very interested in the mysterious object called the human body and the mind. And I take the view that it's so mysterious, so beautiful. It's a miracle, and to say that we have understood it all and is sometimes overstatement. And what I'm going to tell you in the next 2 hours, it's primarily for you. It's not about me. It's about not about my views. You all should, each of you should take away something from this. And at any point, if it doesn't make sense to you, it should make common sense. This whole thing is not about technical or anything. Though I'm deeply interested in what each of you is doing, my handicap is I'm not trained in that. For example, every topic, I'm just going through the list. Every topic is so interesting. So I really cannot, obviously cannot contribute to like effect of Brahmi Grita on age-related cognitive. Everything is a gem. You guys have chosen your topic so beautifully. Um, Cognitive, the genomics, bioinformatics, Vilvadi Gudika, uh, Vilvadi Lehyam, Vilvadi Gudika, then genomics, digital platform to integrate ecosystem, rural livelihoods, antibiotic in cows, ecosystem health assessment, Srivilliputur Meghamalai, tiger, Centella asiatica. What is Centella asiatica?
That's a Brahmi in uh, outside Kerala.
Okay. Autonomous system. Amazing. Okay. So what I'm going to cover this in two parts. I've sent you some reading material, and part one is all about a very commonsensical approach to artificial intelligence, machine learning, data science, um, removed off all the jargons. And part two is my attempt to suggest to you how you can enrich your work either in PhD or later on when when you are into when you finish your PhD into how do we apply all these techniques into your profession in two things. One is defining the problem, exploring problem opportunities. Problems are also opportunities. And third is how do you solve those problems using AI and machine learning. Now, let me share my screen. I'll switch off my video so that we can sometimes everything shared and video can uh, slow down. Can you see my screen? Can you see it now?
Yes, we can see your screen. Now it's in that Excel sheet.
How is coming to Excel sheet? I don't understand. I'm not supposed to be sharing Excel sheet. I'm supposed to be sharing only the
Okay.
PowerPoint slide. Okay.
Either you can share the entire screen or you can select the particular like no window.
Yeah.
Yeah, fine, correct.
It's
Perfect.
okay because what I have to do is I'll have to, as I'm talking, I'll have to switch to my notes, in which case you don't want to be distracted by my notes.
Yeah.
Um, so, see, I have put some slides, but the slides, don't get distracted by the slide because the slides are only more like a reminder for us. At any point, doesn't make sense, you stop me. I don't know how, is there a way to raise your hand? You can do that. Okay. So there is so much hype about artificial intelligence, but forgetting the fact that it's the human brain which created it. right? So they're talking about the equivalence between artificial intelligence and human brain. So this is a very nice, convoluted way of saying that, human brain can never be replicated. You can copy it, you can emulate it, but you cannot replicate it, right? If it is so simple that we can understand it, then it will be so simple that we cannot understand it. So it's like a paradox. So here we will not really talk about whether artificial intelligence is same as human intelligence, the consciousness and all that kind of stuff. We will talk about capabilities. The topic of artificial intelligence replacing human intelligence is a distracting debate. Nobody can ever come to a conclusion. If you look at YouTube videos, there are so many of these debates. Every panel member is very clear about what is AI. But overall, there'll be confusion. The point is not to debate that. The point is to see how can it help me? How can I help? How can it help you? Right? From a very common sense perspective, right? Let's look at what are the tasks that AI does. Many of you know about it. It can identify patterns in a data. See, there are two ways of feeding AI today, right? One is data, which is hard numbers representing the real world. The numbers data is primarily numbers data. Like, for example, you want to characterize a disease and you want to characterize the various conditions. So you give some kind of a, number to a condition, and then the various parameters, body height, weight, and BP, and all those parameters, and then you predict whether I am prone to some disease, right? So you can identify patterns. In a population, you can identify who are, you know, propensity for any particular disease. In a bunch of text, you can look at which are the patterns of certain related terms and all that. Right? Second is classify and categorize. You can classify it based on certain criteria and categorize it. So, simple thing like, you have a picture of various fruits. It can say these are all one type, oranges and apples, or it can be like if you're taking a MRI of a body, it can classify as good cells or cancerous cells or whatever that is, right? Now with generative AI, you can create content. And this is powerful. This is just too powerful, right? It does not necessarily mean it will replace you. You have to rise above it, right? You have to rise above it and direct it. It's a very powerful thing. Second is predicting outcomes of any disaster, outcomes of good things, stock market, disease outcomes. In case of ecology, any kind of ecological outcomes. Next, fifth is extracting relationships, correlations, right? Correlations between, say, a gum disease and kidney, correlation between gut health and knee pain, right? Now, we will see more about it. Correlation is not causation. Very important. Many of you know it, but often in medical literature, especially when it is backed up by vested interest, correlation is always confused deliberately or genuine mistake as causation. Root cause analysis, causation is very hard. Okay. Causation is not easy. Somebody tells you I have a causal analysis engine, don't believe it so easily because it is hard. We human beings also make sometimes mistakes in causal analysis. So correlation is possible. Causation needs a lot more domain knowledge. Transforming data from converting unstructured to structured insights, right? Unstructured could be some text, pictures, audio. For example, you can transform the current audio that I'm talking, you're listening, you're asking questions into a structured, some kind of an insight could be text and, some numbers, how long, who spoke and all that. You have a large amount of document. Point number 7, you can condense it. 500-page document you want to read and you want to go for exam tomorrow, you can say, give me the main points, right? You can condense it. You can personalize experiences. You all know that Netflix and, Google optimization process and decisions, finding efficient solutions, right? So this, please keep this in mind because you are not interested in AI and GI and CI and DI. You're interested in solving problems, right? So isolate yourself from this distracting debate of what is AI, define the problem, and then look for what technology in AI can help me. Remember, AI is not a single technology. It's a bunch of continuum of technologies, right? Anytime, please ask questions. Huh? If I am going to answer it later, I will say so. Otherwise, it's better that we have interactions. We have a lot of material. I don't know whether we can cover it today. So it's important that you understand this earlier part, then we can go together in this journey of 2 hours. It's a long journey. Anybody has any questions, please raise your hand or you can speak up. So all this image recognition, speech recognition, fraud detection, disease diagnosis. So these are all examples, are all use cases. The building blocks are these. The building blocks aren't too many in AI. The building blocks, once you understand them either intellectually or semantically, semantic understanding is also sometimes very good, right? You can build up your ideas into defining use cases like this, right? Now, AI has numerous stakeholders, fans, and you have computer scientists. All of you are either fans or users or masters. If you are a computer scientist, data scientist, you are a master because you are creating. And if you are even philosophy now, right? I'll tell you how philosophy is not religion, right? Philosophy, religion may go together, but not necessarily. Philosophy is a science of understanding, science of logic, science of epistemology, ontology, right? So, and I have a feeling, I have a strong conviction that all scientific and technological um, discovery must be strongly founded on ontology and epistemology. Today, a lot of problems today are happening, public policy, health, and everywhere. Masses are getting deluded, right? Because we don't have ontological and epistemological grounding on whatever we are saying, right? So much things today you hear, fake news. But who decides the fake news, right? Somebody tells me, don't listen to fake news. Okay, so you're going to tell me that what I'm reading is fake news. How do you know it's fake news? So, why I'm saying is, many things appear to you as truth. But if you just ask 3 questions, you will be able to see through its fallacy. Right? Philosophy, that way, to me, is a science of understanding and validating your own knowledge. Right? Now, what is the level of intelligence, right? Many of you who have done some kind of a logic programming, you know that, the past rules were encoded in software, deterministic, if then else, right? If, like an expert system, you feed all your patient data, you feed all your ecological data, you feed all your genomic data, and then say, go for a if then else logic, and then say, this is how this is going to behave, deterministic. Then came data driven. From data, you learn. You learn means the AI learns, right? And now we are going to try to understand counterfactual causality, connections, associations, which is primarily the new world of chat GPT. The new world of chat GPT is primarily text. But don't underestimate text because text is where understanding is. Data is because the way we understand world is not data. The way we understand world is our language and terms. It is raining. I'm having pain. X is suffering from cancer. Y is having a benign tumor. Amazon forest is undergoing deep deforestation. See, it's all words, right? Then you describe the words, you quantify with data. So that's why ChatGPT is going to really revolutionize the way we solve problem. It will also revolutionize the way we are led into group thinking, unfortunately. That is what we have to avoid, right? We will see later. So many things have inspired in the past. Logic, inverse deduction is algorithm inspired by logic. Deep learning. Deep learning is primarily you give it a picture and then the AI engine says this is a cat or this is this X-ray is indicative of arthritis or that MRI scan or PET scan is indicative of prostate cancer. That is through deep learning by giving a lot of pictures and then training it that this means this, that means that, this is cat, this is dog, this is indicative of some clot, whatever, right? Genetic programming has come from evolutionary biology. Probabilistic inference come from statistic. Analogy is clustering. So primarily what I'm saying is no science is isolated. They're all related, connected. From one science, you can easily pick up another science, or you can, that is the beauty of what you're doing, right? You're all into a very important transdisciplinary area, which is, this makes your life very, very interesting, right? So, first and foremost is you have to define what you really want to do. We will see when we go into part two, which is trying to understand what you're doing and trying to enhance and accelerate your work. The first step is, what is the problem? Predictive maintenance, right? I have a machine. I want to do predictive maintenance, means I want to predict the failures or health disease. Health disease, predictive maintenance, we're talking about a lot about cervical cancer now, this one, that one, so many things. There is good and bad in this, and we will see that. A prediction is a prediction, not a certainty. So any prediction can go wrong horribly, right? Fraud detection. We will see more about fraud detection. How do you know somebody is a fraud? See, fraud detection can be easily um, um, what do you call applied to any kind of anomaly detection. Anomaly means something not okay, whether it could be environment, health, or any kind of say autonomous cars, right? Fraud detection, anomaly detection, something wrong. There is something, somebody seems to be about to cross the road. It's an anomaly, right? Loan sanctions, forecasting, everything, right? Now, till now, what you have done is we have looked at, you've had a good idea of fundamentals, fundamentals of AI, which is this fundamental, what it does, and some of the use cases built on this. Now, if you are able to internalize this, you can solve many problems. It's like if you're a cook, you can create new dishes by a combination of frying, seasoning, boiling, garnishing, nuts, fruits, vegetables, cereals. So it's all up to you. You create your own dish, right? If you're a dancer, you look at the basic movement of whatever dance you're learning, and you can create your own stuff. Same with music. Same with, if you're doing cycling, you can create your own style of cycling. So anything, any science or art or any craft has a building block. So this is the building block, and whatever I showed you, right? So now, just to understand, don't worry too much about it. AI is a continuum of technologies. It is not one single technology. Data science, starting with statistics and probability, starting with what? Your what is it? Mode, median, and average, right? Or box plot. If you're a statistician, you'll understand this. All the way up to ChatGPT. They're all one single continuum. They are not unrelated. So don't believe anybody. AI is this, machine learning is this, data science is this. See, life doesn't work that way. It's like saying, when you're eating some dish in the restaurant, somebody comes and bugs you, bores you. Hey, this has got this part you're eating is salt, that part you're eating is masala. So you will not be able to enjoy it, when you go into such level of logic. So don't worry too much about all this. Everything here is a commonsensical approach, like Bayesian learning. Very interesting, Bayesian, right? Bayesian learning is like revising your belief as you progress. For example, you are in a new place. Bayesian learning, let me highlight it. You are a new place and you want to go, you want to eat something that is very favorite to you. Say, what is that? Say pasta. Okay. Now you're going around and you believe that this part of the area, the city will have pasta. But you go there and you see the indications are not that that part of the area will have pasta restaurant or Italian restaurant. So you revise it. You go for so you keep revising your belief as you get more data. Common sense that is put into an algorithm, right? Support vector machines, KNN, text mining. They are all, if you don't get into the algorithm, you'll get caught. Decision trees, deep learning, they are all based on basic common sense. You only have to understand the common sense behind it. Okay. Now, coming to AI, this part I don't want to push too much. What they do is they give data to the AI engine, train it, and once they train it, they test it with a different set of data, because the data which was used to train it, if you again test it with the same data, it will pass always, right? A different testing data is given, and the model, they call it the model, the AI model is tested, right? Now, let's come to the slowly coming to the practical side, right? How much can you trust? There are multiple ways, multiple ways. As you go towards the lower, the human intervention is more. For example, a latest PET scan machine gives recommendations that this area is indicative of some kind of a liver cancer metastatic, right? But does not give the report, does not give you any medicine. And so more like an option. These are the possibilities. Here it is recommendation. Here it is acting autonomously. For example, if a system is there that autonomously takes actions like a car, like a automatic self-driven car, right? It's autonomous. But if a car is giving you some kind of advanced warning that there could be a, you know, something happening on the road, then it's only recommending to you, right? So the dangers of relying on AI for the dangers or opportunities, both. Relying on AI for autonomous decisions depends on the risk you want to take. Suppose you want to open Netflix and then you say, just put on the first most recommended or the best one that you think I will watch. No problem. Suppose you switch on the TV and without giving you all the option, it starts the movie that you want. There's no problem there. It's an inconvenience if you don't like it. But if it prescribes a medicine and then sends it to the pharma person dispatches it, then there is no human intervention. Over medication or under medication could be a problem, right? So you have to be careful about what is the risk of relying on AI, right? AI cannot go rogue. Right? I mean, AI can only go rogue if you will that way. You want it that way. It cannot do anything outside of what you really want. Okay. Now, this is important because every complex technology has its trade-off, right? If you want logic, then if you have a lot of complex problem, then you go for logic. But if you don't know, see, for example, um, uh, if you want to simple example, right? If you want to know whether it is raining, it's not difficult. All you have to do is put a water meter outside, sensor, and say it's raining. If you're inside, in a closed door, and it says it's raining outside, no problem. Logic is required. But if you want to recognize a cat or recognize a very complex ecological outcomes or phenomenon, you really cannot explain how you're doing it, right? I can't explain and program how to identify a cat or how to identify, say, any kind of disease, right? So you have to give it a lot of training. So depending on the problem, you either use logic or probability. Probability means primarily AI and machine learning and data. Now, many outcomes of AI it cannot give you explanation. It can only give prediction. So depending on that, you use the right algorithm, right? Data modeling, algorithm modeling. Through data, you model your problem and the solution, or through you choose different algorithms. See, up to this, you don't have to worry so much about it, right? Just I wanted to tell you there are trade-offs here. These two are very, very important. Solution domain, because problem domain, this is primarily for designers, developers who develop AI. Some of you who want to further go into technology, you may want to understand this more. We can have an offline conversation. But as a user of AI and ML, you have to understand these two things. This is not discussed very openly. False positives, false negatives, right? Precision. So precision is a technical term. It's not the precision that we understand in normal language. Precision and recall is primarily precision is false positives. If I am getting diagnosed for a medical problem and it's a false positive, people tell me false positive is good. Good, no, you're getting treated. But then what about the damage to treatment? So you have to understand what is the cost of false positives and versus cost of false negatives. Now, why I said trade-off is because any kind of an AI engine cannot balance these two 100%. It's like, simple example. Say you're going to the airport security. Now, the security during certain times, during some festivals or some kind of a national, they don't want false negatives. They're okay with false positives. Why? Because the risk of false negative is very, very high. So they are okay to have more and more checks that day, leading to the person being okay cleared for flight, right? But they don't want even as it's like saying, I don't want a single crook to go through the security check, right? But I'm okay to delay an innocent person. Okay. Similarly, in criminal thing also. So it depends on the situation. Now, this is something the human only can decide. What is this context? Okay. So you cannot have both, because you have both, you're not doing anything either properly. But during normal time, security may say, it's okay. I don't expect too many, this is okay. Okay season. I will relax and I will allow more people to go, because the probability of somebody crook coming and going through the security is very remote. It's an assumption. So AI cannot give you 100% thing. Similarly, in disease diagnosis also. What is the cost of a false positive for cancer, chemotherapy, radiation, and the side effect? What's the cost of false negatives? You may say, oh, somebody is having cancer, so false negative means the person has cancer and going untreated. You may take a position that I don't want the person to be not treated, right? So it depends on you, right? Overfitting, underfitting is primarily related. If you train an AI engine to be overfitting, it means if you train it to be overfitted, in the extreme case, suppose say you are training an engine for cats, dogs, and lion and tiger and everything, right? If you overfit, only those cats which are very, very similar to the cat you had trained will say this is cat. The rest will say it is not a cat. Overfit. That's called overfitting. Underfitting is anything resembling a cat, even a tiger will say it's a cat. Why this is important? Stay with me if you are not clear. We will come back to it. Why this is important is because if you overfit, it becomes too specific. If you underfit, it becomes too general. You can't have both. You have to again decide the point, the optimal point based on. It's like saying overfitting means I'm again coming back to medical. I'm sorry if you have any other example, let me know. Overfitting, say for say any kind of specific tumor. If you overfit it during training, it means only that kind of exactly will only say it's a tumor. The rest will say it's okay. If you underfit it, anything that is slightly like a tumor will say it's all tumor. It could be for any kind of a training for any fetal embryonic problems, prenatal issues, right? So I hope you understand this. If you have any problem, let me know. This is very important because this is how you will succeed by having idea of false positive, false negative, overfitting, and underfitting. The technical term here is precision, recall, variance. Don't see the technology world is notorious for misleading everybody. Recall is not the total recall movie or any kind of a recall. Precision is not the same as the precision that we understand. Variance is not the kind of variance we understand. Bias is not the gender bias or any kind of bias. These are all very, very technical terms in the AI machine learning, completely confusing everybody. Okay. So see, same thing I put it here. Anyway, I'm going to share this screen, this PPT with you. We can go through it later. So, they're all decisions. They're all kind of scenarios, right? Let me stop here. Any questions until now? I want to just take a pause. No point in me talking and then I don't know what's going on.
I have a question.
Yeah.
What is the role of AI in current trend and drug discovery as well as biology?
Yeah. So see, I will take those examples of AI and drug discovery, right? Drug discovery, if it go to the molecular or what do you call genomic, what do you call that? Molecular level, there are applications primarily to characterize, target. What do you call that? Target and
Ligand and target.
right? So which molecule goes and targets which kind of recipient? What is it called in the human body? So you can
The receptor based.
Receptor. So you can have AI to predict this based on some parameters you are changing to develop the molecule, right? Second is clinical trials, right? Drug discovery. When I come to the various kinds of research types, exploratory, correlational, analytical, we will come back to that, Sambashiva.
Sure, sir. Thank you.
Huh? Okay, but good question. Can you please remind me when we go to that list of those projects, I want you to ask this question. And if you cannot answer it because I don't understand drug discovery beyond the point, somebody in this distinguished participant group can bring up some topic. But I'll give you my AI and ML driven approach to how we can do it in drug discovery.
Sure, sir. Thank you.
Any other question?
Namita, do you want to ask any question? I saw you are unmuting.
Yes, sir. Actually, I
Please.
wanted to know the. Hi, sir. Can
Yeah,
you hear me?
yeah, I can hear you.
I wanted to know the better example of underfitting and overfitting.
Okay, what is your area, Shreya? Let me look at what you're doing.
Actually, I have not. My name is not there in that.
Shreya, you're there. Digital platform.
No, sir. In that list, my name is not there.
Okay. Oh, Namita. Okay. Sorry. Yeah. Yeah, go ahead.
Yes, I just wanted an example of underfitting and overfitting, like proper,
Okay.
simple example.
Okay. Yeah, simple example. Say, I'll give you a commonsensical example. Easy example is animal. I want an engine that identifies different animals. So what you do, you give thousands of photographs of various animals. Then every photograph, you tell the engine, this photograph is cat, this photograph is dog, this photograph is lion, this is tiger, this is deer, this is cow, right? So what happens is, say you have got around 5,000 cat photographs, right? Now, what the AI is supposed to do is, from this 5,000 cat photographs, if there is a cat which is slightly different, it should take a good judgment that this is also a cat, because it must learn the characteristics of a cat from the pictures. Get it correct? This is how
Yes,
babies
yes.
learn, right?
Yeah.
You can see the babies, they make this mistake and keep learning, right? Now, underfitting is this, right? If it learns too generically, anything that looks like a cat will be like a cat. For example, somebody is dressed up like a cat with a like the mask, or a small tiger cub, which is usually tiger cubs are nice, fat, and very chubby, right? Suppose a thin tiger cub is sorry, just kill this. A thin tiger cub is shown. It might confuse and say this is also a cat. This is underfitting. Means you're too generic.
Yeah.
See, in life also, see, there is no, in life, what happens is you're learning constantly, right? Now, in life, if you are generalizing everything, it is underfitting.
Okay.
If you're too particular about things, it is overfitting. So what is overfitting in the cat example? Only those which are very, very similar to the 5,000 cats will be called cats. The slightly different, they'll say, no, no, not cat. It is learned.
It
So,
is already learned the data.
yeah, no, by learning, some parameters have to be adjusted in the AI engine to ensure there's a balance. You can't learn too generic. See, this is a practical dilemma in life. It's a philosophical problem, right? Now you have an understanding of, suppose you're in a hotel, and it's raining outside, it's very dark, and you want to go to the pharma nearby and buy a medicine, right? Now you're walking, it's raining, it's dark, nobody's there. And then suddenly you start to hear some steps, behind you. And you look back, there's a dark form, hooded, walking behind you. You're walking. What do? You want to run back to the hotel. You might not get the medicine. Your friend is suffering. But if you continue, what if the person, that form comes and closes in on you, and violence, right? So you have to generalize now. Do you generalize that all dark, black coated, hooded forms walking in the rain are crooks? Or do you take a more generic view? I will not decide until the person comes very close to me and takes a stick. You generalize. See, did you get this point?
Yes, sir, I got it. Yeah.
This is underfitting, overfitting.
Okay. Got
Okay.
it, sir. Thank
Everything
you.
milk is white. Everything white is milk. Yes? Underfitting, right?
Underfitting. Yeah.
Yeah. No, overfitting. So if you're very particular, you're overfitted. You're not very particular, you're generic, that's underfitting. Right? See, if you've got the concept, this concept, it's very rarely taught in classes. In AI, they only teach you lots of algorithm, which is useless to you, right? So you got the sense of it, you can go look at the Google and take notes, and try to remember many things. The concept is important. You got bias and variance also? Okay, they're related, huh? They're very related. Very related. The problem is similar to the life problem you have every day. Every day you have this problem of underfitting, overfitting, bias, and variance. Or what is that thing called? I said overfitting, underfitting, and false positive, false negative.
False positive.
Right?
Oh, yes.
Right? So this is a judgment problem, and it's a dilemma. There is no easy answer to this problem. So if somebody tells you I have easy answer, AI does everything, just laugh it off and move away. Okay. Any other question?
No, sir. Thank you.
Okay.
Good morning, sir.
Yeah.
So can you briefly explain bias and learning again?
Which one? Bias and this one?
Bias and learning in the AI. There were some groups,
Oh,
the
Bayesian.
statistics,
Okay, Bayesian
Bayesian
learning.
learning.
Ah,
Yes.
okay. Quickly do a Google if you have mobile phone. See, Bayesian learning is commonsensically, it is like um, you have we all start with assumptions in life, don't we? Correct?
Correct.
And as we progress and get more data, we revise the assumption. Suppose you have lost your passport. Then you start with, I keep my passport in this drawer. But I know it is not there because I went and got my visa and I kept it. I came back. Then you kind of start to create an assumption. I must have left it in the car. So you start with that. Then you go to car. It's not there in the car. Then you start to revise it. Oh, I had a bag and the bag was, I took the bag and bought groceries. And then I took out this part because I have to put vegetables there. I must have left it in the grocery shop. So you revise it. From the car, now you have gone to the grocery shop. So similarly, when you are searching for an answer, any kind of an answer, you are continuously revising your beliefs. Okay, so Bayesian approach is used in many applications, like, search and rescue. Like when air crash, when MH370 Malaysian Airlines disappeared, apparently the consultants started using Bayesian approaches. When Air France AF447 crashed, long ago, they used Bayesian approach, Bayesian techniques to pinpoint the area where the wreck could have been. So I'm sorry to take a very negative example, but Bayesian approach is primarily starting with an assumption and continuing and changing your assumption as more data comes. As more data comes, you revise the assumption, you revise your belief. So you are zeroing in on the solution. Clear?
Yes, sir, clear. So
Okay.
one more question.
Yeah.
How do I use AI for generating content? Any
Oh, very
specific?
easy. Very easy.
Yeah.
We'll come to it. I'll show you some practical examples.
Okay, sir. Thank you, sir.
The content I generated for you, let me reveal to you, I use ChatGPT a lot. Okay. Did you like it? Thank ChatGPT, but also thank me because I kind of led into giving you what you would love to have.
Okay.
Thank ChatGPT and also Mahesh.
Yes.
If you liked it. If you don't like it, tell
Yes,
me.
I liked it, sir.
Okay.
Yes.
Okay. So I think we have to reach a world where we should be open about using AI. I don't know, Dr. Vishnu, am I, creating a revolution and a revolt here that I will use ChatGPT for answer?
No, it is nothing like that. I mean, like, no, it's very important to share this information so that we will, all of us, it's not that the students, all of us are students in that sense.
Yeah.
Appropriate, sir.
Yeah. So my cleverness is primarily, working with ChatGPT because ever since Dr. Vishnu told me a month back, I started to engage it. Come on, tell me, no, this is not okay. No, this is not going to help them. I had you in mind, all of you. What will help you? I could have done it over 6 months or 3 months. It accelerated what I wanted to do. Whatever I did for I created it, I could have done it myself. Sat and wrote down everything. No point. If it is not relevant, it's because I did not give it proper prompt, did not give it proper context. Okay, so generating content is very good, but be very careful. It might give you very irrelevant information, wrong information. Every time you have to check for logic, correctness, and cross-verify. But it is very useful. Okay. So there was a last week I was in a conference and I was talking to some academic professors in was it Italy? So there was a debate between two set of professors. One professor said, ChatGPT, I will allow my people to use. But if they Don't work hard. I will come to know it is ChatGPT. Right? Others said, no, 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 no. I will do all kinds of checks and I'll ensure that they don't use ChatGPT. So the world is divided. I am of the view, how does it matter? Did we not use, when I started my career, they said, don't use calculators in class. Now we are using calculators, right? So human beings must rise above machines and work with the machines, not be threatened by them. Okay, but this is not a statement of any kind of policy of an institute. So whatever the policy of the institute, please follow. Otherwise, they will not, Dr. Vishnu won't call me again. I won't have the pleasure of interacting with people like you all. Okay, clear? Okay, let me go back. Able to see my slide? Okay, so this is good. AI holds huge promise for individuals, society, companies having different objectives, right? So the challenges, I said, right? Many times AI doesn't have explainability. It gives the answer, but you don't know how it gave the answer. An epistemological approach is lacking. Correlation is not causation. We will see some examples of that. Then lack of counterfactuals, refutation approach. Let me, 1 minute. Yeah. Counterfactual. Counterfactual is a big problem, especially in medical today, right? Imagine this. Imagine this. You're able to see the screen, no? Able to see the
Yes,
screen?
sir.
Okay, imagine this.
Yes, we can.
So you have a preventive medicine. Okay. And you give the preventive medicine. And the person lives long. There is no way of knowing if you are not given the preventive medicine, how long the person would have lived. This is the crux of any preventive medicine because counterfactual for biological systems is impossible. Impossible. But this is the basis of very vaccines. I am neither saying vaccines are good or bad. I'm only saying there is no way anybody can claim any prevented something. I can say, I, because I was with this person, when this person was traveling in the night, this person was not pickpocketed. Can I say this? I can say it, but can I prove it? I can't prove it. This is the problem for intelligence agencies. They can't prove that because they did something, something was prevented. What would have happened if that had not been there? For example, if I give a medicine to a person and the person lives, now you can't, or the person dies, I can't say, let me put him back to life and give a different medicine and see how long this person will live. That is counterfactual. The counterfactual is what if I had not done that? This is the biggest challenge not discussed in medicine, leading to many problems. Here, I leave the conclusions to you. The motivations could be genuine, sincere motivation. The motivation could be commercial motivation. But what is important is not to find fault and criticize others, but to be aware of it. So counterfactual is important for life. It's also important for you as a researcher, right? This will make your reasoning very sharp. Any questions on this? Very important part. Okay. So, see, Suppose you say students who practice yoga regularly tend to score better in exams. Correlation. Can you come to the conclusion yoga causes higher academic performance? See, I believe that yoga can cause higher performance and experience of life. Okay. But scientifically, you can argue the underlying cause may not be yoga, but because they are managing the time very well, they are overall very careful. They are very careful with time. They are very systematic. They do yoga. So that is why they score well. You can refute it. So correlation is not causation. IIMs, Indian Institute of Management, transdisciplinary university, or IITs, or NITs, or top colleges in India, they produce the best students. This is a statement of cause. But the correlation is top universities, top graduates. Now, you can argue because they were very good, they were very intelligent, very systematic, and very committed, very passionate, they got through the entrance exam. So whoever goes into IITs, IIMs, or TDU, or any other institute, they're already good. So they come out good. Or you can argue, TDU makes, IITs make, IIM make great output. So this is correlation. Correlation, causation, they are not same. Causation is difficult, right? Now, please take this carefully. Don't use it everywhere, every time to your bosses. They may not like it. There are two things, right? One is your logic. It may be, you may be a great logician, but don't try your logic everywhere. Be very, very careful in applying logic. Here, my job is to equip you with great weapons. Those weapons must not be used there. They will cause problems to you unless you are a social activist. Okay, got this? No? I want to see all of you when I say this. Get it right? Be very careful. You cannot go and tell your boss or counterfactual, actually there's a problem. I don't agree with this, your conclusion. Be careful. Your boss may not like it. Okay, or when you join a company. But be aware that there are issues with counterfactual, causation, and correlation. This is clear to you all?
Yes.
No? Very important, huh? Very important in science. Okay. And somebody has put a hello, sir. When was it? 10:48. Okay. Okay. Let me share it again. So this slide that I showed you is very important slide. I'll send you some examples. So hopefully you will use it, but keep it to you as your Brahmastra. Don't use it every time. It may cause problem to everybody in the world. Okay. P-value. We'll come to P-value later. Powerful tool, but can be deliberately or inadvertently wrongly used. Okay. P-value, you all know. How many of you know P-value? You must know. Okay. I think I'm going a bit slow. I have only 1 more hour. I have to score. Okay, challenges fitting data to say many challenges is AI and machine learning. You would keep the data, fit that to hypothesis, remove all the other data. Finding patterns where no meaning exists, right? Irrelevant predictors, higher number of predictors. Okay. Now, predictors is primarily the factors which are leading to outcomes. If you have too many predictors, too many things you have chosen, then it might confuse the AI engine, right? That is also a problem. I'll come back to this because this needs a lot of Dr. Vishnu, do you think I should cover this a bit more or we will leave it?
I think this we can leave because students are already like, had some decent idea on this.
Okay, okay.
There is one, message from Arun. Is traveling and can I raise that question now? Can I ask that
Yes,
question?
yes. Yeah, please. Yeah.
Is there a way to triangulate or cross-check the results by GPT? For example, I have used a couple of AI tools to generate images of historical context, traditional practice, etc., among tribal communities and so on. And what are the ethical concerns of using AI in academic activities research? This is the question I don't pose.
Okay. See, if you want facts, right, please use Google or any research academic site. If you want to generate ideas and you want to correlate and connect and associate things, use ChatGPT. Okay. Now, ethics of using ChatGPT, that is very subjective. I don't want to go into the ethics in an academic world, right? Because academic world is now thrown into a big disarray because can I generate a paper using ChatGPT? Theoretically, I can, right? Is it okay to generate ChatGPT generated paper? Suppose you generate, how will the reviewer know? If it is too, if you just take it as it is and go and submit, everybody will know ChatGPT. Okay. So the ethics of it, I don't want to comment. So we would rather discuss what is the institute rules about it and comply with the rules. Dr. Vishnu, is this the correct, appropriate answer?
I think so. Yes, that is because you can use. I mean, it is our maturity to take. When this is the same sentence that I tell my students as well.
Yeah.
There is nothing wrong in using any technology, but you should have that. You should draw the limit.
Exactly. I can tell you one thing, if you just say ChatGPT and we don't apply your mind, it will give you very, very absurd paper. It takes a lot of logical thinking and creativity to use ChatGPT in a way your outcomes are delivered. Okay. So to me, ChatGPT is not a cakewalk. Hey, ChatGPT, generate a paper on correlation between cognitive decline and air pollution. It will generate something for you, which, you can submit it, but you may not get good marks. But if you take the pain of actually going through and then giving that prompt and, giving up, working with it over the next 15 days or 1 week, you may see results, right? Okay. So it needs sharpness, intelligence to use these technologies. Okay. So I'm going to share my screen again. So good. Keep those questions flowing. I'll speed up a bit here. So there are these serious problems that have happened where AI. See, somebody. Hold on. Some charge. Yeah. So. So Google flew, right? A few years back, Google said based on the search, they will be able to determine where the flu is. Okay. So it worked because people, when they had some kind of a symptom, they were doing a search in Google. I have this symptom. Is it flu? What medicine I should take? So as a numbers in a particular area, as they increase, Google gave this verdict that this area is now going to have flu. But initially, it worked very well. They were able to predict any outbreak of flu, right? But later on, it caused a lot of overestimation because the algorithm didn't have any causal, it only correlated, but not causal intelligence. It didn't have any epistemological or epidemiological grounding, right? So what happened? The net result was lots of false positives. Suddenly somebody said that area is full of flu and nothing really happened. So cause a lot of unnecessary work for public health authorities. So again, correlation, not causation, right? So this you can go through it, how you have to, balance between bias, variance, and precision and recall. I'll send this to you anyway, right? Explainability and transparency are a bit of a problem, because often they tell you, ChatGPT or anything tells you the answer, or the AI engine will give you a verdict of whether something is a cancer or something, some kind of a problem, but it does not necessarily tell you why it is saying so, because it's all only learning from data. It's like a kid, right? Kid tells you, but doesn't explain to you, cannot explain to you what and why the kid is saying that, right? So primarily uncertainty in predict. See, when you predict, when you're doing any research and you're doing any kind of a prediction, the earlier you predict, the better for everybody. But the earlier you predict, there is more uncertainty. So you have to be careful at what is the optimum point. Say, if it is raining today, the actual event, and say it's raining or it's about to rain because the air is saturated with water vapor, and I predict, no big use, but it is accurate. The accuracy is very good. Uncertainty is very, very less, but not useful. But if you want to predict it's going to rain in the evening, the morning itself, it is useful. Okay. But it's not necessarily certain. I may go wrong. So this part you have to be careful when you're designing any programs that claim to predict something. The earlier you predict, more uncertainty of false positives or false negatives, but more useful. The later you predict, more certainty, but less useful. So this part you have to have, because this, by learning this, by understanding this, your ability to take advantage of AI engines will be much, much better. You will not go wrong unnecessarily, right? Trusting the AI engine, right? Causality, there are lots of this, you can go through it, how the causal inference can cause a lot of problems, right? Some suggestions of books, you can go through it, how AI is great, but how AI can also go wrong. Okay. Don't always use AI, because it will be as though the solution is looking for a problem. Here is a nice hammer looking for a nail. So this is primarily a thing that whatever happened through the ages in automation, the human beings can never go out of fashion, right? So you and I, provided we are, continuously learning, understanding, creating, critically thinking, we can never be replaced by AI. Not possible at all, right? So key consideration, you have defined the problem, you define the success, you define level of intelligence, as I already told you, realize the cost of poor performance, false positive, false negative, decide the algorithmic or the tool in this case, and then you ensure that you are doing continuously quality audits, right? Okay. Now, I also told you, look at some nice, hilarious examples of how correlation, causation are not same. This is, I'm again and again saying, because this can be a big kind of a showstopper for you, right? Okay, so there are risks here. Conceptualization, there could be unethical use cases, data management, incomplete data. So data is absolutely important in AI. If you don't have accurate data, incomplete data, complete data, your AI inference could go completely wrong. We will see the case study. We have some time for the case study. We'll see the case studies, how data is very, very important, right? Non-representative data, sample size, everything is important. You can go through it later. Now we come to now that you understood AI and, seen that, there are pitfalls, there are huge promises, you have bias, variance, precision, recall, correlation, causation, then data issues. Now we go to the now, see, you have huge opportunity, because you are in a transdisciplinary area wherein, you connect human body, you connect technology, you connect ecology, you connect Ayurveda, connect allopathy, homeopathy. There are so many of these things, right? How do you connect all this? You cannot do it using manual analysis, right? For example, you are an Ayurvedic practitioner or you are an expert in Ayurveda. You want to start to combine or do an integrated Ayurvedic allopathy medicinal system, right? Now, how do you convert this whole model of Vata, Pitta, Kapha in Ayurveda into a corresponding approximate model as seen by allopathy, right? So you have to read through a lot, but you ask AI, AI is able to give you a lot of connections and relationships. By itself, it won't give you the answer, but it will actually help you map these two various disciplines, right? Or you want to connect a tool available today, drone technology, and you want to map the drone technology, various technologies with mapping the terrain of, say, uh, Western Ghats forest. You want to map. It's difficult for you to sit and do this mapping. Mapping is not the terrain map. I want all these various flora, flora and fauna and the terrain kind of a characteristics with the tools that are available today on the drone. It will give you those connections, those association, like a table, right? You want this, you can use this, that kind of stuff, right? Just a small example, right? So this, like, there are some of these, what do you call, software or technologies that help you predict 3D protein structures with very high degree of accuracy. Blue dot, AI-enhanced climate models reveal region-specific warming patterns. Um, NASA's Perseverance rover, AI and banking. I don't know any of you in banking. If you're anyone who is outside of ecology and medicine and well-being, let me know. Then we can look at those examples. You can raise your voice, or you can raise a hand. We can look at more technology like domain banking, for example, or finance or any such things, right?
Yes, sir, I am from unmanned systems, autonomous unmanned systems.
Tell me.
Sir, I am from unmanned autonomous systems. My research.
Okay, like self-driving cars and all that?
No, sir. It's called Oscar, Optimized Swarm Cognitive Automated Response. It's about, I'm from the armed forces. It's from weaponized systems.
Weapons, is it?
Yeah.
Okay. Can you repeat that? I don't think I understood. What was that?
Sir, my topic is on optimized swarm cognitive automated response. So it's kind of a white blood cells response to a situation wherein the mind and the hive doesn't work together.
So in the defense system.
Affirmative, sir.
Huh?
Yes, sir.
Okay, very interesting. Okay, something like a control system which will quickly detect threats and make a response.
Correct. Correct.
Very interesting. Very interesting. So you have a combination of so many. So you have to continuously sense dangers, assess dangers, prioritize the risk, and formulate your response, either
Correct.
defensive or offensive.
Correct. And sometimes it is premeditated. That means as soon as it senses, it will, instead of taking a defensive action, it takes a preemptive offensive action to stop the response.
Yeah, preemptive strike. Very interesting area. Very relevant and very useful for countries continuously facing dangers, right? Very good. So, which means you will use a lot of multimodal sensors.
Affirmative, sir. And that's why interdisciplinary becomes quite important, because my responses are done by aerial systems, but my sensors are on ground, underwater, and everywhere else. So they might sound similar, but actually each of them work in a different environment, leading to a different kind of perspective. And the issue is of sensor fusion also, so that they come on a common platform with the different ICDs, getting them to think alike and take a decision, reactive or proactive, is quite challenging.
And your name is, it says RV.
Yes, it's Commander Rahul Verma, sir.
You're in Air Force?
I'm a naval helicopter pilot, sir.
Still serving?
I just retired, sir.
Oh, wonderful. which is what's your RB? Which name is which is the
Sir,
topic?
RV is
Rahul Verma. Okay,
Rahul
okay.
Verma, Rahul Verma.
Exploring geopolitical implication of uncrewed autonomous systems and swarm technology. Swarm, okay, the swarm intelligence, huh?
yes, sir.
See, swarm intelligence is a great example of how you can use AI. Because swarm intelligence, I see many of you see this can be used in human biology also. Swarm intelligence is primarily individually, each of them will exhibit very simple behavior. But collectively, they are complex, like birds, they call murmuration, I think, right? Birds.
Affirmative, sir. Burmaration, then there the word called boyed, which is the use to describe swarm, came out from the activity from the nature itself. So the word boyed itself is from the nature, and the inspiration for it's been, it's not today, but it's been from 1800 when you start following bees. And the queen bee became, but queen bee is not a network distributed brain, but it's a common brain being followed by leadership model. From there, the murmuration came out, and that's how the network distributed, I will say, responses or brain started working, sir, in layman language.
Hmm. No, very important because see, being all of you in a TDO area, you can, if you just go read into any of these, you can apply it anywhere. See, swarm intelligence can be used in curing targeted, like nanoparticles, I think some graphene or something, right? Where they go
Affirmative,
in,
sir. Affirmative.
uh
Yes.
right? So the microcosm are often very similar, but they're not same. So you have to be careful. All this initial guidance system. So there is so much opportunity for you to use AI, and so after this, you plan to take join a defense organization.
Sir, presently I have joined Bharat Forge, sir. I'm associate vice president at Bharat Forge, Baba Kalyani's company, sir.
Okay. Wonderful. I think we should have a chat. Definitely others.
Sure, sir. I can share
Yeah.
my initial thesis, which I have filed. The initial thesis, if I share, you will understand. It's basically based on Storm because my guides and all are not from the same field. So it took me some time to explain them what I'm doing. So I can take someday, maybe the whole student and everybody can look at my subject for PhD, sir. It'll give you a lot of idea about how it works.
Yeah. So if time permits, no, I will give some examples as to how personally I have benefited from completely unrelated topics in my area, right? Especially biomimetics, biomimetics mimicking the bio system, in technology and vice versa, right? So these are the research types. So you have, you can do a mental analysis of what your work is, each of you, right? Descriptive, which is primarily understanding. Analytical is primarily explaining. Exploratory is again more going into where um, there is no initial information, but you apply something called principal component analysis to understand in a exploratory way about the topic, right? So basically, when there are so many factors, the PCA helps you reduce the dimensions, right? Correlation research, which can be used anywhere. Correlation between, it can be national intelligence, can be disease intelligence, ecosystem, can be, um, you know, any kind of ethnic studies, genomic studies, bioinformatics. Experiment is primarily your cause-effect relationship. Longitudinal research is very interesting. This is primarily over time. How are the disease? Interesting thing is, like prostate cancer, right? Or cancers which are usually they take a long time to kill the person. They say prostate cancer is such that the person, the organ outlives the patient. Means you could die of something else, but not prostate cancer, right? So interesting because that will help us understand whether intervention is required. So intervention is a problem sometimes, right? Whether it is, intervention in your domestic life, you don't intervene, right? Beyond a point. You don't go and tell your kid not to do something. Intervention, you don't tell always. You tell sometimes. It cause problems, right? Or you don't go and intervene things that are not really required at this point. At what point you want to intervene, you can always do a longitudinal research and try to understand. Cross-sectional, different groups, case study, evaluation applied. Now we'll see how you can use various techniques. Now, be careful here, right? Do not worry so much about what exactly it is, because all you have to do is, let me put this on the pointer. All you have to do is define your problem and give a descriptive understanding of what you really want to do, and then map it to the technique, right? So, for example, your descriptive, what you're doing, you're clustering. You're clustering this country, various cities based on certain kind of parameters, pollution and health outcomes, right? So you can take targeted action on those cities, right? So this can be, you can predict the likelihood of a person developing a heart disease based on many factors. So you kind of analytical or explanatory, right? Analytical here, explanatory is primarily, you do the principal component analysis, which is primarily the large number of factors contributing. There will be a lot of overlapping factors, which are not very obvious. So you reduce those dimensions so that your work becomes easy. Then you have correlational. Correlation is Pearson correlation. This is very basic in statistics between X and Y, right? Between, say, bronchitis and some, say, Parthenium seeds, right? Or it could be any kind of correlation between drugs and some side effect. Clinical trials, experimental research. Just stop me if you have any question, because I don't want to go through it completely. If you have any question, I'll stop and explain. Otherwise, you can go through it. I have given this in your material, right? So cross-sectional research. Decision tree is primarily giving a tree of how a decision is primarily made. This is a technique used in machine learning. As you can see, machine learning AI are a bunch of techniques, right? Patient history, public health campaigns, and blah, 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 blah. So many things are there. You can go through it. It's quite self-explanatory. Now, what I want to do now is, before I go to the case study, I want to understand, I'm going to bring up that participant material version 2. Okay, now I have given some suggestions based on my study and some kind of I took some license in, creative license in giving some suggestions for each of you. Any of you have any questions on this? Does it make sense at all? Anybody says, no, it doesn't make any sense to me, sir. I'm okay with that. This is not, I'm not passing any test. I'm okay. Do you have any questions on that suggestions I gave you? Open that participant material. I don't want to go through one by one, but some illustrator.
1 second.
Anybody has any questions? Then we'll go through the case study, spend some time going through each of this. No, nobody has any questions? It made all of you made sense?
Hello, sir.
Hmm.
So I had a question. I'll be designing a digital platform for the tea plantation community in Darjeeling. So you have suggested me to develop a user-friendly, sustainable livelihood digital platform. So I wanted to know, so what are the critical knowledge and consideration a person working in design thinking should possess while developing the prototype, so that and integrating AI and machine learning aspect in order to ensure that it's a user-centric, ethically responsible, and technically feasible for the people, as it is a rural area. So
Yeah, so let me understand this. So what you're doing is developing a digital platform to integrate ecosystem stewardship and rural livelihoods, promoting ecologically sustainable communities in Darjeeling plant. So digital platform will take all the local information about livelihood and all that, right?
yes, sir.
Socio-ecological work, huh?
Yes, sir.
Okay. So what have I said here? I've said,
Sir, may I ask a question on her what she said? So
yeah.
so the data set is based on what census which is gives her. The data set will be, suppose, from the period of 1960 to 2024. That will not be able to give the right answer, because since the millennial or 2000 Y2K bug, after that, the use of various technologies have improved the livelihood in that area. So the responses from 1960 to 2000 will actually corrupt the data. That's what I think. So that's why I asked this question, especially when it comes from a place which is based on a census which is happening every year, and which does not cater for the kind of environment or the how do I say, the situation on ground, how different it is.
You're saying the data will be outdated?
I am saying the data will be corrupted, because from 1960 to 2000 and 2000 to 2024, if we take that period, there's a lot of difference in the overall GDP of the country due to the kind of open trades and everything else the country did. And also the technology has improved the output in those areas, the farming output. The socio economy changes quite a bit. So do we think that we take up the whole data, or how do we add filters to stop the corruption of the data?
Yeah. So what Shreya is trying to do is build a platform. I think her topic question was more of what are the considerations, right, Shreya?
So,
Yeah.
yes.
So yes. Correct.
Yes, sir. I was talking about the considerations.
Yeah. So first of all, you are collecting socio-economic data, right? Social, social, ecological, right? So what kind of people, their livelihood, their what do you call, say, their earnings, and then you're also collecting data on the ecology side of things, right?
Yes, sir.
So what you have to do is, first of all, create a data model. Okay, you look up. A data model is primarily, a data model must reflect reality, right? So you must create a data model which is models the social side and the ecological side. So what kind of, then decide what data you want to collect. Point number two, once you have this data model and what kind of data you want to collect, then you collect it either from databases, from land records, or through interviews, through surveys, right? Third is you clean the data. You clean it up means, ensure that after collection it is completely, there is no incomplete data, there are no contradictions, you statistically check. Then fourth is, you have to also, it's not clear to me what is the outcome you are going to come out of this. I mean, you're saying digital platform, what will it improve finally?
So it's a kind of development of a business model, economic model for that area, where the traditional products of that area has been declined. They are not getting the market valuation. So I'm trying to develop a digital platform where not only the tea, as Darjeeling has a GI tag, but of tea, but it has declined due to in a certain period of time. And similarly, the products of Himalayas are declining. So I wanted to give it a platform where these products will get a market valuation for a longer period of time.
So, so considerations are these, like, you first, create define the objectives. What are you trying to improve? Are you trying to improve the GDP? Then you also have to look at, the negative factors, like, boundaries, like, you should not be, the counter things, like, the ecological balance should not be disturbed. For example, green cover or whatever you want to look at, right? So once you define the objectives, you create a data model, what data you want to collect, you collect the data, you cleanse it, and then you define what are the activities that are required for you to improve the livelihood. Now, for the challenge you have is the AI scenarios or use cases you have to define. For example, you go back to some slide I told you. Do you want correlational intelligence? Do you want to conduct an experiment and do like an exploratory approach where you conduct some experiment and see what is causing, what combination of factors can maximize the objective, which is the income, while not affecting the ecological parameters. Whatever you have decided, that parameters, you have to define the metrics, right? So you have to look at how the AI can help you, right? So, for example, let me go to that, to the first one. Go back to the common sense, right? I'm sharing the screen. So this is how everybody can do it. It's not only for Shreya, it can be for anybody. Go to the basics. Can you see my screen? Can you see my screen?
Yes, sir.
Yeah. So see, what can you apply here? Do you want to identify patterns of socio ecological clusters? For example, people with lower income are, concerned with this, or they're living in certain parts of the Darjeeling, you said, no? Darjeeling, right?
Yes, sir.
Okay. So you want to identify some patterns, so you can use AI, right? You want to classify. You already defined certain classification parameters, like, economic status, or maybe classification based on the terrain, right? Now, generate content. For example, this can be used for your reports, right? You want to predict some outcomes based on the factors. You want to extract relationships from some data that you have collected. You want to transform data from the data collected unstructured through interviews to a structured insights, right? You have a large volume of data you want to summarize. Personalized doesn't make sense. And then you want to optimize the process, which is primarily tweaking the inputs to maximize the outputs. So it's important for you to define your objectives and the overall, what is the platform going to do? Who are the stakeholders? Is it going to be used by the locals? Is it going to be used by the purchasers of the products? Is it going to be used by the government people, or social NGOs? Then, accordingly, you have to define the platform capabilities and design the cap. Don't get into the technology at this point. Technology comes easy, actually. So have you decided the stakeholders? Who are the people who will use the platform?
Yes, sir. I've decided that this is mainly the rural communities and um, uh, the small scale entrepreneurs who are going to use it.
Okay. So this is what you have to do. You have to define the users, and then what kind of information, input, output they will give. Will they input? Will they output? What is the data model? How the model is going to help you? What are the levers? See, it is not that the data is going to be information. What are the levers in the real world you will be applying to maximize your objectives? Your objectives being whatever you decided. So these are the considerations you have to take into account while defining the platform. We can discuss more about it, Shreya, because I don't understand completely your thing. It seems quite interesting. We can have a separate discussions on this. I can give you my
Sure.
views.
Sure, sir. Thank you so much, sir.
Anybody else? Neurogenerative, sacred spaces, very interesting. Shrinking habitats, human marsh, crocodile ecology, relations, traditions, the evolving dynamics in India. Looks like a very explorative, descriptive. You want to understand more about it. Am I right? This is Yashendu Joshi. Okay, then this
Sir, Yashendu is not there today. I think, no, I don't know why.
Yeah, no problem.
Today.
So, right. So look at this, and then now let's look. We have around 37, 11:37. We have half an hour. Okay. Where is the structure I gave you? Yeah. Let me go back. Now, can you spend 5 minutes on this case study? I'll show you this, which I think I believe I have 1 minute. Maybe what I can do, I can divide the participant into 2 or 3 groups because not everybody is interested in biology. I've given 3 case studies. So you can choose which one you want to look at. Give 5 minutes to go through it, and then we can ask some question answers because it's just an ocean. But what I want to do is now I want to ensure that finally at the end of the day, you're users of AI. So which means you have to break your problem into very explainable, easy to explain solution. I mean, easy to explain problem statement. 1 minute, I'm just going through the case study. So I have 3 case studies. One is the air pollution and cognitive decline, and second was Amazon rainforest resilience, and third was Ayurvedic integrative medicine. So it's 11:38, 11:40. Can we just quickly regroup at 11:45? Then we have 15 minutes to discuss the ideas and the illustrations given in this. I've chosen this with a lot of, I've tried to be representative, but I don't think I have covered everybody. Can we just quickly read through this? All the 3 case studies, whatever interesting to you, one of these you take, then we'll have discussion on it. 5 minutes? I mean, in fact, 6 minutes only because we don't have much time. Or if you can extend it, Dr. Vishnu, I can extend. I'm okay with the participants. I don't want to eat into that time. Today is a Saturday for me. I have no problem.
Yeah, I mean, here I'm also okay. If the participants are fine, we can extend. That's not an issue.
We'll extend as long as required, and up to the point the boredom sets in for you all.
Yes, sir.
Please go through whatever interests you.
Hello, sir. Good morning.
Yes.
I'm Sunaina, sir. I'm pursuing my MSc in biological sciences by research at TDU. Sir, I wanted to know how AI-driven behavioral modifications and engagement is explained, or how can we implement that? So, can you give an account on it?
AI-driven behavior modification.
Yes, yes.
Your topic seems to be on antibiotic use in dairy cows, right?
Yes, sir. I am asking with the curiosity of after studying that case study 1.
Okay.
Yes,
Good thing you've asked us. Which part of it you looked at AI-driven? See, AI-driven modification in this case study, if I remember what I wrote there, it is like continuously checking your vital health parameters and then correlating that with your lifestyle. And
yes,
then see, listen to me carefully, huh? When we define the problem in plain language, whichever language, English or whatever language, it becomes easy to apply any AI technique, easy to understand. So what I'm saying here, right? In this, if I'm not mistaken, there is one clause. Let me go to that particular place. Ayurvedic study, yeah. Personalization part, right? So
yes,
here, what I have given is, see, there is lifestyle. What I do, all the activities I do, right? Second is my health parameters, right? And there is a correlation between these two. Correlation sometimes can be taken as causation for a practical purpose. Don't worry too much about it at this point, right? And then consistently understanding this correlation and saying that The days, for example, simple, the days you have exercised, those days, your BP is stable. Stable. Maybe high, but stable. So, for you, there is a strong correlation between exercise and BP. BP, right? Or the days you not slept well, there's a correlation between that and BP. Or the days you took some particular food. So here, it is very personal. It's not a one size fits all. What helps for me may not help for you. I've seen one thing, not every exercise is good for everybody. You may not respond to an exercise, I may respond to it. You may not respond to a particular food, I may respond to it. So in this case, I have carefully chosen it, how you can personalize your personalize your approach and drive a behavioral change. So consistently based on this correlation and outcome, correlation between outcome and your lifestyle, you are prompted to focus and continue, sustain certain aspects of your lifestyle. Clear?
Yes, sir. So, how AI is implemented in a sentiment analysis. So, I didn't understand that part. Like you were talking about the chatbot in the case study. So,
Yeah.
how can it be detected sentiments of a person? How can it lead to an analysis of a sentiment?
See, in this, what I assumed in when I designed this case study is there's a chatbot of the app. See, these are all case study, right? And I've used some poetic license to assume certain things. There is a chatbot. The chatbot, the person is expected to write about how the person feels that day. I got up today in the morning. It's like a diary, like a journal. I got up in the morning. I felt great. So that I felt great is recorded by the chatbot and it tries to correlate using AI machine learning techniques with what is correlatable with this I feeling great. And throughout the day, I write, I'm feeling low. I'm feeling energetic. I'm feeling depressed. I feel like working today. Or my activity for that day has been very high. I may not have said something, but I record all my activities. Today I did cycling. I worked for 3 hours. I spent time with my family. On days based on the sensors, maybe I've been sleeping or I've been taking rest. So all these parameters are taken and normalized. See, the fact that the person that day wasn't active is a sign of, on a working day, is a sign of something wrong. I may not have put that in the chatbot. The fact that on a Tuesday or on a Wednesday and a non-holiday, which AI knows, I have not been active. Neither have I been moving around. I mean, horizontal, because sensors know the orientation, right? This is and sentiment is what I write. Sentiment could be, I may even copy and paste I may even talk to it. And every day I talk to it over 6 months, it's able to understand my sentiment. Sentiment analysis is you do a Google search on sentiment analysis. It's an algorithm that senses sentiment and provides a characterization model of the person. Clear?
Yes, sir. Sir, I have one more question on the case study 3. So
Yes.
you were talking you had given about a cognition and pollution related case study.
Yeah.
So on that, you had mentioned it in that how the brain structure would change due to the pollution exposure. So how can you tell that, sir? How it changes.
The cognition, see what happens now. This I know it's debatable. Okay, the structural change in the brain is primarily, it's not about the brain physics, it's about the chemicals, right? So the pollutants is bound to have functional change in the brain, right? When I say structure, see, maybe I meant functional change, may not be structural, right? So now people here in this call have to tell me, I took some poetic license here. Is Alzheimer's and dementia a result of structural change or a functional change? Functional change means, the chemicals and all that, right? Will the functional change, or say the chemicals in the brain, will it cause some physiological changes? It's an hypothesis. See, what I have written here is cognitive test results from psychological assessment like memory recall, attention span, executive function tests were integrated into MRI scan that showed the structural change in the brain. The structural changes could also be something to do with some kind of a benign tumor or something like that. So because of a lack of specialist knowledge in human anatomy and physiology, I might have put some words which are not 100% correct, Sunaina. Forgive me for it, but you get the
It's
point.
all right, sir. I understood like some part of it, like you were talking about the pollutants and how it influenced the function of brain as such.
Yeah.
So
See,
that part I got it, sir.
yeah. So look at it this way. In this study is primarily correlational. If you look at all the thing here in this pollutant and the cognitive, it's more of correlational. Means, see, in practice, even though I told correlation is not causation, correlation has to be taken as causation for the purpose of concluding your study. Otherwise, you will be asking a lot of questions. If you follow me 100% right, you can never finish something. You'll keep on. So here, even though it is correlational, for all practical purposes, using your common sense, you can say these are all causal link. That's why I use the word very carefully, causal link between pollutants and cognitive impairment. Okay. Others are listening. If you are not reading, are you all agree? You all agree with me?
Sir, till the time you don't have
Yes,
the
sir.
data set, causation has to be used for the particular set for coming on to the conclusion, right?
Yes.
Because otherwise, there are gaps. If I, like you rightly brought out in her field, it's not my domain, but the way you just brought out, I understood that we can use causatives to get to conclusions.
Yeah. See, correlation has to be complemented by your domain knowledge on the causal pathways. The causal pathways are applicable in any domain. Causal pathways are applicable in biology. They're applicable in air defense, civil defense, in countries' defense. They're applicable to ecology. The concept of causal pathways, that is, you bring to your study, your research, complementing the correlation is what will give you conclusive, the confidence. You got what I'm saying? Otherwise, sometimes you may mistake, but you have to complement your correlation with with your causal. Yeah, it makes sense. It makes sense. Yeah, this leads, the pathways of your human body or whichever it is. Now, if you have read through it, any questions on this? First of all, did it make sense? Did you anything is very, very difficult to understand. If you correlate, if you connect it, whatever the case study I have put with all the techniques in the PPT I'm going to send you now, you will understand it very easily. You don't need to understand AI. All you need to understand is those 9 use cases. Simple. 9 use cases. And look at the research types I gave you, and say, what is your research type? And then use your creativity to apply AI ML. Like if you're a cook, look at the ingredients and do a creative mix of. If you're an artist, look at the various basic building block and put them together. Any questions? even questions that you don't really know how to ask is okay, because this is a difficult subject, very difficult subject, but it can be made very easy, interesting, rewarding if you just get the basics and commonsensical aspect of it. Anybody has, see, we have 7 more minutes, and I'm okay to extend it, but I want to kind of put the sense of urgency so that we cover a lot more. Anybody has anything specific on their respective project? If I had time, we would have gone through every case study, but I had to really cover the initial part.
Yeah, this is very important because we cannot live without all this kind of information what Dr. Mahesh has given. So anybody has any question, please?
Yeah.
I'm strongly encouraging everybody to use this. And certainly, sir, I'm going to have a completely separate session personally with you because I have a lot of things. I'll share
Yes,
that
looking
separately with
forward.
you, sir. Yeah. I
I'm
mean, I don't
looking
want
forward to it. Yeah.
to mix it with this class. Go ahead. Go ahead, Swati, if you have anything.
Oh,
Yes,
just
sir.
I was about to ask you about this Brahmi Grita and cognition. Yeah,
Hi, sir.
absolutely.
Hello, sir. Sir, I saw your input on my topic where you have mentioned it as EEG analysis and machine learning classifiers.
Hmm.
So I wanted to understand, because EEG analysis we didn't take up in our study because of the challenges, because it's a community study and we visit the participants rather than participant visiting the hospital. And that was one of the reasons why we didn't take up the EEG study. And second thing, when you mention it as machine learning classifiers, I really I didn't understand that term. Well, like how to use this in my study. I had this question, so I just
Yeah.
wanted to your inputs on that because I didn't
No,
understand that.
good question. Good question. So let me rephrase your project. You are looking at Brahmi Grita
Yes, sir.
on age-related cognitive changes.
Yes.
Okay.
Yes.
Now, when you say age-related cognitive changes, obviously you would have quantified what are these changes.
Not really. I mean, we are just checking with the normative data that is available in the Indian population in various domains, like memory, concentration, attention, and few of the questionnaires that we are using it like stress, sleep, anxiety, which are directly correlated with decline in the cognitive cognition. So these
Yeah.
are the only things that we are
So
looking.
some observations you will pick up.
Yes.
See, when you say cognitive changes, some kind of either observation or measurement you will collect on some
Yes.
population. What is the size of the population?
The age group is 25 to 70. That is the age group, and we have divided it into two portions. One is the younger adult, which comes from 25 to 55, and the older population from 55 to 70. Because we have normative data till 60, but our team has developed a normative data for till 70 years. We had a good population to develop the normative data that we are using it. So this is the age group.
So only thing is, the question I had was, how do you, I mean, suppose I say that I'm an old man, okay, and what do you observe to say that there's a cognitive change in me? You will measure something, you will ask me some questions, or
Yes, sir. We have some of the internationally accepted cognitive tools like MOCA, which covers your memory span, concentration span, and how well are you able to follow my instructions and remember and recall things that we ask you. Like we have some test where we ask you to draw some diagrams, which you have to remember. And first portion you have to copy them by immediately seeing it, and then we ask you to recall it, and after 20 minutes again you have to recall it. So there are some dictation portions where we read a list of 15 words and we learn it for 5 times. So your learning capacity is also captured here. And then we ask it after 20 minutes. And there are some portion where we ask you to recognize from a big list. So these are the small things that we do
no, this
in
is
order
very
to measure.
interesting.
Thank you, sir.
Okay, now what you do, okay, you replace EEG with this analysis or this observation or the test or whatever evaluation you're doing.
Hmm.
EEG, I just took something because I didn't know how to measure cognitive decline. Is it EEG? I mean, I don't know. See,
So we have another
right?
portion in the study. We do MRI also for the participants.
Uh,
See the structural and physiological. I mean, some changes if there is any ischemic changes or structural changes that is seen. So we do that also. So based on the pre and post, by measuring different parameters in MRI, we come to a portion that okay, structurally there is not much of change or activity wise, and the cognitive tools also adds on to our study.
okay. So I don't have any drawing tool. So this is the cognitive, the outcome,
Skills,
the
yes.
cognitive changes. Okay. This is your Brahmi Grita,
Hmm.
right?
Hmm.
And this is the population,
Hmm.
right?
Hmm.
Now you want to know by administering Brahmi Grita
Hmm.
to this population.
Yes,
So there are two parameters: how long, how much,
yes.
right?
Yes.
Some may, and in what form are you giving it in?
Yes, sir. We have two groups again. One we are giving in extract form. Other is in the Brahmi ghee from Ashtanga Hridayam that we are taking. That is a classical form. And these are the two forms that we are using.
Excellent, excellent, right? So both
And
are
duration
important.
is for 3 months. Yeah.
Okay. So you're not varying that duration. You're only having two
No.
groups.
Yes.
3 months, and then you're measuring this whatever the outcomes
Yes.
before 3 months, and you're
Hmm.
measuring this after 3 months.
Yes.
Right? Now you can take this very simple and not use any AI at all.
Mm-hmm.
Okay. Now possibility for you is if you want to scale up this, there are two ways of using AI and ML. One is when you observe, you can observe a lot of things that are, see, there are two ways of observation and measuring cognitive change. One is that set, you already decided.
Correct.
Memory, coordination, recall, A, B, C, D, and you do it for everybody. And then you
Yes.
look at these two population and say who are not taken, control group and experimental group, right?
Yes, we have.
Now, to enhance your work, theoretically, you may not have time to do all this. See, PhDs, I know all of you have to finish it off. You can't be idealistic. I know PhDs. All this talk that I'm giving you is input for you for future life. Okay. Today, whether you can use, I don't know. You have to finish it off and go, right? But I'll give an idea that you can ruminate on, right? Suppose I just observe the patient. I take unstructured notes, like my mom, right? I take, at what point of day is she very alert? What point of day is she not alert? When she recalls my name, all that, right? You're going by the set parameters. You're also going by unstructured observations.
Yes.
Right? Now, once you have the unstructured observation, lot of data unstructured. Lot of data related to the lifestyle, related to the past lifestyle, the food habits, families, whether there are people. See, there are people living with the patient also improves cognition.
Yes.
Right? So all these are write down. Now, what you can do as a human being, you can't do anything. You can only go through it for another 1,000 years and then try to make sense out of it.
Yes.
This is where AI classification, clustering, it can start to give you meaningful clusters of people who are showing a particular trait of behavior or outcome. Okay, which are outside of what you have thought through. So it's enriching your study. So you will, even as you are looking for a specific outcome, you're also discovering new outcomes, either negative or positive.
Yes.
Yeah, I never knew this. Actually, Brahmi is improving the mood. Brahmi is actually helping this person sing better. See, you don't know.
Yes. To add on to this, actually, we have a questionnaire which we have prepared to 12 questions, a small questionnaire, where we ask the participant how you're feeling pre the intervention and post intervention. So we are collecting that data also, wherein, as you rightly mentioned, there were a few participants who told, I'm feeling more energetic and active, which wasn't there in my structured neuropsychological batteries.
Exactly.
So these
Exactly.
are the things that are there, which
So if
we
you have
are
1,000 people, if you have
Ah,
samples of 1,000 people, you cannot go through it manually, right?
yeah, right, sir.
See, some people say, I take Saraswata Rishta, I'm able to sing better. Is that an intended consequence outcome of Saraswata Rishta? I don't know.
No.
Right? Same thing with Brahmi, Ashwagandha. So there could be unforeseen benefit or adverse effect that can be discovered using machine learning AI. Okay. And we can discuss what could be those techniques. Systematically, you have to do it. And remember those 9 things. That's all you have to know. Then get a AI ML employed, and then you discuss your language, your terms, your terminology. That person discusses. Semantic bridge is required. I use the word semantic bridge between 2 domains, the AI domain and the domain of your choice, whether it is ecology, genomics, bioinformatics, or defense. You have to have a semantic bridge between these two. What is semantic bridge? You define the problem and you translate that into a machine learning technique that I spoke to you about. Right? Those 9 things. Those 9 things in turn can be translated to the actual technique. Remember, the 9 things were very English oriented, right? Classification, clustering, sentiment analysis. They're English, right? Those in turn can be translated, mapped to specific tools available in the market. This refinement you don't have to do. So you don't have to at all feel threatened by any technology, because all you have to do is systematically break it down into an area up to a point where you can hand over to the AI person. Okay. So this is very useful, Swati. I mean, EEG discounted. Replace EEG with any other outcome measurement you are making.
Sure, sir. I'll do that. I think the subjective parameters that we are collecting, I should be able to convert it into some sort of data, to understandable data
Yes.
from me using AI.
Yes.
I'll do that. I'll come.
Yeah.
Just
See,
discuss with
Anagha has some edible figs and can we use image recognition to classify, right? And then those classification can in turn be correlated with some nutritional value in those different classifiers, which in turn can be correlated with some what if somebody takes figs, what will be the outcome, right? Customer preference model, nutrient simulation algorithms, and Manoj, right? So any other question you have? Incorporation of iron and protein development, yeah. So Dr. Vishnu, I am done. If there are no questions, I hope this was useful to you. I hope I'm telling you, first time I am actually addressing a transdisciplinary crowd. I've always addressed a very homogeneous crowd. So if this is useful, thank God. If it is not useful, please tell me.
Well, first of all, it is really it was very useful, and this is what is actually this student should understand. And though I'm not from this background, I had some exposure to AI and ML on my research. That's what I would like to separately discuss that with you. So. Uh, I mean, there is absolutely no doubt how useful this lecture. Now, again, I mean, students, I'm sure they will have more, questions, and probably I can share your email ID so that,
Yeah.
I know your busy schedule, but still they can write email, because that is, you can, reply to that as per your convenience.
Yeah.
Yeah,
What we
maybe
can do is, if you have any questions on the material, or you have any questions on your work that you can enrich either now or later, we can schedule a discussion. I'll really definitely find time to give my. I don't want to just kind of say something and go away. It's part of my, I would say, commitment to take it to a point where all of you find this useful, and at least you are inspired to do something more than what I have spoken today.
Yeah. Certainly, that is required. And also, I feel, I mean, it's my personal opinion that all of us who are not really trained in AIML, I think that we also have some kind of a confusion because it's pretty like, new in terms of possibilities. And as they were asking, like, the ethical aspects and a lot of things are there. So that also will be, something that we also have to learn more on this. So,
Yeah,
uh,
actually, the problem today is that, people teach you, I mean, you only want to drive a car, not to learn how to repair a car,
exactly.
right? So all you have to do is, what can the car do? It can take you, and then the semantic bridge between the car design and you as a user. Clutch, brake, steering, oil change. That's all.
Yeah. Yeah.
AI is simple if you use it that way. I mean, it's like using any gadget today, at home or in office.
Hmm.
But it has been made so complicated and distracting conversations on whether it is intelligent or not. How do you
Hmm.
care? It doesn't have human beings they're always at the top. Don't get distracted.
Yes.
Only define the problem,
Yeah.
refine it up to a point where a specialist can help you.
In that context, I have a very quick question. What is your take on the trend of new what I can say courses at the masters and graduate level, specifically focusing on AI and things like that? Is that really helping us in educating people about AI, or is it like sort of distracting us from the fundamental knowledge? What is your take on that, sir?
See, what I would have preferred is outcome driven training. See, today I could have covered a lot about what is KNN algorithm. It wouldn't have made you any wiser. Unfortunately, there are no classification of the persona based, right? So the AI, oh, we will include AI. What are you going to include?
Hmm.
I mean, are you going to suppose what you're using Minitab for statistics? What are you using?
Statistics.
Uh, SPSS.
Yeah.
Right, like this. There should be things like, we will teach you today how to use ChatGPT properly, ethically, in a way that is helping you. That's all you have to know. You don't have to know about large language models. Or you can say, we will teach you all those 9 techniques and how, see, those 9 techniques or use cases. The nine use cases, how to translate those 9 use cases into your problem. Image recognition use case can be used anywhere, right? It can be used for surveillance, can be used in Digiyatra, can be used for X-ray analysis, can be used for cancer detection. So you have to decide how each use case can be translated. This is what we have to teach people, and that shouldn't take more than 3 months or 1 month or 1 week. But they have a half year course on AI/ML. Why?
Agree.
Dr. Vishnu, am I right? I mean, do you all agree with
I mean,
me?
I agree with that, sir. I agree
Right.
with that.
Right.
And
So,
this trend is there for all knowledge area. It's not only AI, but I agree with that.
yeah. So my suggestion to you is, stick to what you really want and look for the answer.
Correct.
Start with the problem definition, and then you can slowly refine the problem up to a point where technology can help you.
True.
This is the mental model you have to develop.
True. True.
Like I hope in each of you, some of you ask questions. I hope I led you into that. I was attempting to lead you into a point where you don't know. I'll give it to somebody. That's it.
Correct. Exactly.
That's what, right?
Exactly.
Yeah.
Certainly, sir. Yeah. Thank you very
Okay.
much. And any other questions from the
Yeah.
participants?
Yeah. Thank you. And any
If
questions later on, you have
yeah,
anything, please, we can have a call, Dr. Vishnu. We can have schedule a group call, small groups,
Sure,
and
we can do
then that way maximize.
Yeah.
Okay.
Maybe I request Shreya to please formally thank the speaker and conclude this session.
Yeah.
Thank you, Vishnu sir. And good afternoon, everyone. So today I feel very honored to share a brief summary of today's insightful session on the role of artificial intelligence and machine learning in collective knowledge and their transformative role in our day-to-day life and our research. So today our speaker, Mr. Mahesh Venkataraman, took us on an engaging journey through the real-world application of artificial intelligence and machine learning, especially in the fields of health, wellness, and environment. He showed us how different research types make us use of specific AI technique, making even the most complex data set meaningful and actionable. So today we learned what descriptive research works, analytical research, correlation methods, experimental models, and longitudinal studies in the context of clinical trial and forecast disease progressive over time. And beyond this, sir has also introduced us how powerful AI tool help us like identifying the patterns, predicting the outcomes, summarizing the information, optimizing the decisions, and even personalize experiences in ways that we were unimaginable that it will come just a few years from now. So, and his insights highlighted that AI isn't just a tech buzzword; it's practical, powerful, improving human life, and it is also driving smarter research and shaping more sustainable futures. So on behalf of all of us today, so I'd like to extend my heartfelt thanks to Mr. Mahesh Venkataraman for sharing his deep knowledge, practical wisdom, and for inspiring us to think critically about it and how to use AI and ML responsibly in our field of research. So thank you once again, and thank you everyone for this attending the session. And
yeah, and also I want to tell you that all of you are the future, because today there is so much silo today in technology and every field. I think I'm very happy to see this whole schedule of this program, like reflective, epistemology, ontology, then innovation. I think we have compartmentalized disciplines so badly that everybody is thinking, their own respective thing and not creating a holistic view. Countries which have done very well are countries which have people like you who think holistically. And we need more of you. We need you to do more.
Thank you, sir. Thank you very much.
Thank you, all of you. Take care.
Yeah.
Thank you,
Okay.
sir.
We will
Bye.
continue our discussions
Yeah.
outside the screen, sir. Certainly. Yeah.
Thank you.
And once again, I welcome you to our campus. Please, let me know.
I will. I definitely want to meet all of you.
Yes.
It will be nice to have informal discussions on areas that you're working on. Right. Thank you.
Okay. Thank you. Bye, everybody.
Thank you,
you,
sir.
sir. Thank you.
Thank you, sir.